Welcome back to the deep dive.
Glad to be here.
So picture this. You walk through the doors of a major department store, right? You're just, I don't know, maybe looking to buy a pair of socks or a coffee maker.
Oh, I know exactly where this is going.
Right. And you have to run the gauntlet. You step onto that shiny tile and just boom, a literal wall of air hits you from the cosmetics and perfume counters.
It's intense.
It really is. And for a lot of you listening, there's this immediate, totally involuntary physiological response, like a tightness behind your eyes, maybe a throbbing tension at your temples, or just a sudden, uncontrollable cascade of sneezes.
Yeah, it happens instantly. I mean, most of us have either experienced it firsthand or, we share an office with someone whose cologne just lingers in the elevator for 20 minutes.
Ugh,
And
yeah.
everyone else is just forced to take these tiny, shallow breaths until they reach their floor.
Exactly. And we usually just write it off as a mere annoyance, right? Like,
Right.
oh, that specific perfume is just too overpowering. But today, we're pulling from a really comprehensive medical review published by Healthline to decode the actual biological reality of these fragrance reactions.
It's fascinating stuff.
It is. Our mission today is to map out exactly what happens in your body when you inhale that department store air. We're going to look at why your immune system might be treating a simple botanical extract like a deadly pathogen, and, most importantly, how you can reclaim your physical environment.
Because that physical response you experience, it's not just about having a really sensitive nose.
Right.
You're experiencing a profound, cascading biological reaction to an environmental stimulus.
Yeah.
And understanding the mechanical difference between how the body categorizes those stimuli is really the only reliable way to find relief.
Okay, so before we map out the whole cellular response thing, we have to look at the environmental input. Like, what are we actually dealing with here? We're breathing this air in, absorbing it through our mucosal linings, but identifying the actual substance is, well, remarkably difficult.
It is. And the scale of the problem is huge.
Yeah. The Healthline Review highlights this 2009 survey revealing that up to 30% of the U.S. population experiences irritation from perfume. 30%.
And it gets worse. 19% actually suffer documentable physical health effects from it.
Wait, 19%?
Yeah. Nearly 1 in 5 people is experiencing adverse health outcomes from products that are designed entirely for, aesthetic pleasure.
That is just wild.
Right. The scale of those numbers shifts this from just an isolated hypersensitivity issue to a widespread public health blind spot. And it's heavily compounded by our regulatory frameworks.
Yeah, the regulatory framework is where this becomes genuinely opaque. I mean, you turn over a bottle of lotion or a room spray, and you see that single word on the ingredient list, fragrance.
Just that one word.
To a consumer, that reads like a single additive, right? Like sugar or salt. But legally, because of protections around commercial trade secrets, that one word operates as a placeholder for over 2,500 unlisted chemical compounds.
Over 2,500, it's staggering.
It's the equivalent of sitting down at a restaurant, opening the menu, and the only word on there is food.
That's a perfect analogy.
Right. It conveys absolutely zero functional information about the hidden ingredients you're about to ingest. Or, in this case, inhale and absorb straight into your bloodstream.
Is this lack of transparency the main reason people struggle to identify their triggers?
Oh, absolutely. The legal protection of a commercial formula in this instance just directly undermines consumer safety protocols because they don't have to tell you what's in it.
Exactly.
The fragrance loophole was originally designed to prevent competitors from reverse engineering iconic perfumes. But today, it just allows manufacturers to bundle hundreds of synthetic stabilizers, fixatives, and aromatic chemicals under one umbrella term, creating a massive diagnostic wall for the consumer.
Yes. You might figure out that a specific body wash is the source of a severe skin rash. But identifying which of the 100 hidden chemicals within that wash is the actual trigger, it's virtually impossible.
So you're basically left playing a game of biological Russian roulette with every new product. You can't even check the label of a new detergent to see if it contains the specific compound that caused your last reaction.
You really can't. The regulatory gap shifts the entire burden of safety squarely onto you. You cannot rely on the manufacturer's label for a threat assessment.
You're on your own.
You are. You have to monitor your own systemic responses and recognize the patterns of your own physiological reactions, simply because the product labeling is legally permitted to withhold the data you need.
Man, that is frustrating. So the sheer volume of undisclosed chemicals floating in the air explains the scale of the problem, but it doesn't explain the massive variance in how humans respond.
Right, the biological side of things.
Yeah, like why does one synthetic compound give someone a mild headache while another triggers full-blown hives in someone else? To understand that, we have to look at how the body actually categorizes these incoming chemical signatures. And people constantly mix up two distinct medical terms here, a sensitivity versus an allergy.
All the time.
Yeah.
And the distinction dictates the entire treatment protocol.
So when people say I'm allergic to your perfume, they're probably using the wrong word, right? It's like calling a food sensitivity a peanut allergy.
Exactly. The vast majority of people suffering through that department store gauntlet are experiencing a fragrance sensitivity, not a true allergy. Calling a chemical sensitivity a perfume allergy is a massive misclassification.
Because it operates on a completely different biological pathway.
Entirely different. Let's look at sensitivity first.
Yeah.
It functions basically as an expulsion response.
An expulsion response, okay, meaning the body wants it out.
Right. A sensitivity is your body's localized reaction to a synthetic or chemical irritant. The body registers that this abrasive substance has made contact with the airway mucosa or the epidermal layer, and the biological imperative is just immediate clearance.
It initiates an eviction protocol.
Yes. The body uses physical mechanisms like sneezing, a runny or stuffy nose, rapid postnasal drip, coughing, to just flush the chemical irritant out of the system.
Using excessive mucus production and forced air.
Exactly. And the symptoms might include a vascular headache or even mild nausea just from the sheer physical strain of that expulsion effort.
But the defining characteristic is that this response is primarily localized and transient, right? Like once you remove yourself from the department store and the irritant dissipates, the mucosal inflammation subsides relatively quickly.
Yes, it does not trigger the systemic immune cascades associated with an allergy. An actual allergy, which functions as an invader response, is an entirely different biological mechanism. According to the data, a true allergy is a specific immune system reaction directed not at a synthetic chemical irritant, but at an organic protein structure. And the body classifies that protein as an allergen.
Okay, so the immune system's primary directive is to hunt and dismantle dangerous biological pathogens, right? Like bacteria, viruses, parasites.
Right.
Which are fundamentally constructed from proteins.
Mm-hmm.
So if the immune system is functioning like a really sophisticated facial recognition software, is it essentially getting fooled by a hyper-realistic mask?
That is a great way to put it.
Like it scans a protein structure within a natural lavender absolute or a botanical extract, registers a contour that closely mimics a dangerous viral envelope, and then just triggers a massive coordinated defense.
That's exactly what happens. The immune cells possess surface receptors that physically bind to specific molecular shapes.
Okay.
When the protein structure of a totally harmless floral extract successfully binds to one of those receptors, the system assumes a pathogen has breached the perimeter. It does not differentiate between a rose extract and a bacterial membrane.
Oh, wow. So it just goes to war.
It registers the breach and releases a flood of inflammatory cytokines to aggressively dismantle the surrounding tissue where the perceived invader was detected.
And the resulting collateral damage is severe. The localized tissue destruction manifests as an intensely itchy red rash, scaly or dry skin, crusty or oozing blisters, hives, even a severe burning sensation, and increased photosensitivity.
It's brutal. And because the immune system has logged this specific protein as a hostile target, the response isn't transient like a sensitivity.
It lasts a lot longer.
Yeah, the reaction develops over several days as the immune cells mobilize, and the tissue damage can take weeks to resolve, even after just a singular, brief exposure to the perfume.
The body basically commits to a prolonged siege against a phantom threat.
Well said.
While the contact dermatitis and mucosal inflammation of a sensitivity are highly disruptive, we have to examine the physiological threshold where this misidentification actually escalates into a systemic medical emergency. Because for a distinct subset of the population, the immune response does not remain localized to the skin or the nasal passages.
Right. And this is where we transition from avoiding a rash to recognizing a critical, life-threatening threat.
The source outlines specific emergency symptoms indicating the immune system is losing regulation. Swelling of the mouth, the lips, or the tongue that begins to hinder speech or respiration. That is the primary indicator of a systemic cascade.
The most extreme manifestation is anaphylaxis. The airway tissues rapidly inflame and the passages literally physically constrict.
It's terrifying.
It is. This catastrophic failure of regulation is driven by a massive overproduction of a specific antibody known as immunoglobulin E, or IgE.
Now, since IgE is an antibody designed specifically to protect us, is this anaphylactic response essentially the immune system overreacting with such violence that it critically endangers the host, all to neutralize a perceived yet non-existent threat?
That's exactly it. IgE antibodies evolved primarily to defend the body against large parasitic infections. But in a severe allergy, the immune system manufactures a disproportionate volume of IgE targeted precisely at that specific, harmless perfume protein.
So it's bringing a bazooka to a knife fight.
Worse, it's bringing a bazooka to a non-existent fight. These IgE antibodies bind themselves to the surface of mast cells, which are immune cells just packed with granules of histamine and other inflammatory mediators.
Like little biological bombs.
Exactly. When the perfume protein enters the body and cross-links with the IgE on the mast cells, those cells rapidly degranulate. They dump massive, overwhelming quantities of histamine directly into the bloodstream simultaneously.
And histamine is a vasodilator, right?
Yes.
So it signals the endothelial cells lining the blood vessels to contract and pull apart slightly. This increases vascular permeability, causing blood plasma to rapidly leak out of the vessels and into the surrounding tissue.
Which is exactly what causes that sudden massive swelling in the face and throat.
Simultaneously, it triggers the smooth muscle encasing the airways to violently spasm and constrict, and the rapid loss of fluid from the vascular system causes blood pressure to just plummet.
It's a cascading systemic failure. It requires immediate intervention.
Typically an injection of epinephrine, right, to forcefully constrict the blood vessels, relax the airway muscles, and stabilize the mast cells.
Yes. Epinephrine overrides the histamine cascade entirely. And the source also flags secondary systemic indicators that require immediate medical intervention, even without airway constriction.
Like what?
A body temperature exceeding 100.4 degrees Fahrenheit, sudden cognitive confusion, extreme lethargy, a rash that rapidly advances across the body, or the emergence of painful purulent boils. All of these indicate that the immune response has breached localized containment.
So you cannot just wait out systemic confusion or a rapidly spreading rash at home.
Absolutely not. You need a doctor.
Okay, so understanding the mechanics of a systemic failure highlights why intervention is so critical there. But assuming you are safely at home, experiencing the more common localized reactions, like a tension headache from a chemical sensitivity or a painful patch of contact dermatitis from an allergy, we have to look at the mechanisms of actual relief.
Right, the everyday treatments. The fundamental baseline for treatment is complete avoidance. The trigger must be physically removed from the environment.
Scrubbing the perfume from the skin, heavily ventilating the room, or getting rid of the scented object entirely.
It's a prerequisite. No secondary treatment will successfully suppress the immune or expulsion response if the body remains in active contact with the irritating compound.
Makes sense. You can't suppress a physiological alarm while the button is still being actively pressed.
Exactly.
So once the environmental trigger is removed, targeting the lingering biological response requires specific interventions. For mild symptoms, we're talking oral antihistamines medications like Zyrtec, Benadryl, or Claritin.
Right. They operate as competitive antagonists.
Meaning what, exactly?
Well, they don't stop the mast cells from releasing histamine. Instead, they bind to the histamine receptors on your tissue cells. They're essentially blocking the landing pads so the circulating histamine cannot trigger further inflammation.
Oh, that's clever. And for localized skin damage, topical corticosteroids, like hydrocortisone, can penetrate the epidermal layer and modulate the gene expression within the cells to actively suppress the production of inflammatory cytokines.
Those are the standard pharmaceutical interventions, yes. They target specific pathways in the inflammatory cascade. But there are also targeted natural therapies that repair the compromised skin barrier without introducing additional, potentially irritating synthetic compounds.
Like using heavily vetted, unfragranced moisturizing lotions?
Yes, which provide a protective lipid layer over the damaged epidermis.
Now, I want to talk about the standout intervention detailed in the Healthline review because I love this one. It leverages the specific biochemistry of colloidal oatmeal.
Ah, yes. The pantyhose trick.
Yes. Constructing a localized compress by enclosing cold water-soaked oatmeal inside a permeable membrane, like a clean pair of pantyhose. It provides highly targeted relief, and it is wonderfully accessible and cheap for anyone listening at home.
It really is, and the science behind this pantry staple is fascinating. Oatmeal contains a unique group of polyphenolic compounds called avenanthramides.
Avenanthramides, okay.
Right, and they actively inhibit a specific protein complex within the cells known as nuclear factor kappa B,
And why does that matter?
because that protein complex regulates the transcription of DNA and the production of pro-inflammatory cytokines. So, inhibiting it physically halts the cellular signaling that drives the redness, swelling, and intense itching of contact dermatitis.
Wow. And using the pantyhose allows the water-soluble avenanthramides to pass through the fabric and interact with the damaged tissue while containing the messy particulate matter of the oats.
Exactly, no messy bathtub required.
Brilliant. Now, there's another intriguing treatment pathway highlighted in the source, and I'm really curious about this one. Photobiomodulation, or light therapy. Can you explain exactly how shining a blue or red light on the skin can calm down an immune response?
It sounds like sci-fi, but it's very real. Utilizing specific wavelengths of blue or red light mitigates the immune response and manages secondary complications. Red light operates at a longer wavelength, allowing it to penetrate deeply into the dermal layers.
Okay.
It interacts directly with specific photoreceptors within the cellular mitochondria, basically upregulating cellular metabolism. This shift in energy production alters the local tissue environment, suppressing pro-inflammatory mediators and accelerating tissue repair.
So red light speeds up healing. What about blue light?
Blue light, conversely, operates at a shorter wavelength, so it remains concentrated at the surface of the skin.
Which is highly relevant for an allergic rash that has blistered or cracked, because the mechanical barrier of the skin is broken, leaving the underlying tissue vulnerable to secondary bacterial infections.
Exactly. Blue light is deeply antimicrobial. It induces oxidative stress within the specific porphyrin molecules produced by surface bacteria.
Meaning it kills them.
Yes. The light essentially forces the bacteria to generate reactive oxygen species that tear apart their own cell membranes from the inside out. It rapidly destroys the bacterial load on the compromised skin without requiring broad-spectrum topical antibiotics.
Which is huge, because those antibiotics carry their own risk of triggering additional contact dermatitis in a highly sensitized patient.
Precisely. Now, for individuals caught in a cycle of these severe cutaneous reactions without a clearly identifiable trigger, the medical review heavily emphasizes contact allergen patch testing administered by an allergist.
Right. They introduce microdoses of highly common isolated chemical triggers to mapped sections of the back, and then observe the localized immune responses over several days.
Yes. It effectively bypasses the fragrance loophole on product labels by physically mapping your body's exact threat matrix. It replaces anecdotal guesswork with hard clinical data.
So once you have identified the precise molecular structures your immune system is targeting, managing the transitions from reactive treatment to proactive environmental control.
Exactly. Treating a reaction is good, but preventing one is always better.
But controlling the environment in a culture deeply dependent on synthetic scents requires deliberate structural changes. Scented products are embedded in literally everything, from office cleaning supplies to municipal waste bags.
Creating isolated safe zones is a real logistical challenge today.
It is. If you choose to utilize personal scents, the primary strategy the source recommends is selecting natural plant-based perfumes with minimal restricted ingredient profiles. The mathematical probability of encountering a specific chemical trigger drops significantly when a product relies on 5 transparent ingredients rather than a proprietary blend of 2,000.
Absolutely. And in shared environments like an office, where you lack control over the personal habits of your colleagues, implementing localized air filtration is highly effective.
Like keeping a small air purifier at your workspace.
Yes, specifically one equipped with an activated carbon filter. Having it directly at the workspace physically strips volatile organic compounds and synthetic fragrance molecules right from your immediate breathing zone.
Environmental control also requires vocal advocacy, though. Communicating your specific chemical triggers to colleagues and management is essential.
And we're seeing progress there. Scent-free workplace policies are increasingly standard. Human resource departments are finally recognizing that chemical sensitivities and severe contact allergies are legitimate, ADA-recognized medical conditions, not mere aesthetic preferences.
Thank goodness for that. And in your personal living space, creating a zero-tolerance baseline for volatile organic compounds is critical. Removing all plug-in air fresheners, heavily scented candles, and aerosolized room sprays gives your immune system a sustained period of downregulation, which reduces your overall systemic burden.
That concept of systemic burden is deeply tied to a highly counterintuitive preventative measure outlined in the medical review.
Oh, freight, the flu shot.
Yes, maintaining an annual flu vaccination.
Wait, I have to stop you there. How does a flu shot have absolutely anything to do with my coworker's heavily scented cologne?
It sounds strange, I know. But the connection between a viral respiratory infection and a dermal reaction to a cologne hinges entirely on the concept of immune bandwidth, or allostatic load.
Immune bandwidth. Okay, explain that.
When the immune system detects a massive, replicating, viral pathogen-like influenza, it upregulates its entire surveillance network. The baseline level of circulating pro-inflammatory cytokines spikes as the body wages a system-wide war.
Right, your whole body aches. You're feverish.
Exactly. With the immune system already operating in a state of high alert and systemic depletion, the threshold required to trigger an inflammatory response to a minor environmental irritant drops precipitously.
Oh, I see.
The regulatory mechanisms that normally suppress a reaction to a stray synthetic chemical are exhausted. By utilizing a flu vaccine to prevent the massive physiological drain of a severe viral infection, you actively protect your baseline immune resilience.
So an unstressed, fully regulated immune system possesses the bandwidth to successfully ignore a minor chemical irritant, whereas a depleted, hypervigilant immune system just does not.
You've got it. It's maintaining the structural integrity of your immune regulation.
It's the biological equivalent of dropping a pen on a normal day versus dropping a pen when you're operating on 2 hours of sleep and under immense stress. You just snap.
Exactly. The baseline state of the system dictates the severity of the reaction to a minor stimulus. Protecting the system from massive viral disruptions indirectly preserves its ability to tolerate minor chemical ones.
That is fascinating. So synthesizing this massive amount of data we've covered today, the core reality is that the term fragrance on a label is functionally meaningless as an identifier. It's just a legal shield for thousands of unregulated chemical compounds.
It really is.
But by understanding how your body reacts to that complex chemical load, whether it initiates an expulsion protocol to clear a synthetic irritant or launches a coordinated immune siege against a misidentified protein structure, you gain the operational knowledge to actually manage the fallout.
Right. You shift from suffering unpredictable reactions to implementing targeted strategies. You can identify specific triggers through patch testing, utilize receptor antagonists or specific wavelengths of light to manage cellular inflammation, and systematically strip those volatile organic compounds from your controlled environments.
So the next time you find yourself holding your breath in the cosmetics aisle, you understand the invisible mechanics at play. The air is saturated with thousands of undisclosed, legally protected compounds, forcing your mucosal linings and immune receptors to make millions of instantaneous threat assessments.
Which forces a much broader evaluation of our modern environments, honestly.
How so?
Well, think about it. If a single, ubiquitous regulatory loophole can introduce thousands of synthetic chemicals into the air we breathe under the guise of a fresh scent, it highlights a fundamental mismatch. We really have to consider whether the sheer volume and complexity of the synthetic compounds we encounter daily are rapidly outpacing the evolutionary capacity of our immune systems to accurately categorize them.
What else is hiding in plain sight? A vital question to consider the next time you encounter a product masking its chemical reality behind the word fragrance. Something to mull over. Catch you on the next deep dive.